Hello, this is Leslie Fafita with Providence. Today we'll be talking about how to run Aermap with BEEST. A short overview of what we'll be talking about in this webinar. We'll do a little overview of the Aermap preprocessor program for AirMod. We'll talk about how to identify your domain using a utility we call CalcDom. We'll talk about how to obtain the elevation data that you need for your AirMod run. We'll talk about how to convert that elevation data into a format that Aermap understands. And then we'll go through the process of building our Aermap inputs in BEEST. We're going to look at the region of the files that are imported by Aermap, and we're going to talk about some options in Aermap. Then we're actually going to go ahead and run Aermap. We'll go ahead and do a little side note here about partitioning your Aermap run, which will make it go faster. And then we'll take a look at the outputs. Okay, in general, Aermap is an AirMod preprocessor. It has to be run before you run AirMod. Aermap is used to estimate receptor elevations, and BEEST also uses Aermap to estimate the elevations of emission sources and buildings, although it's primarily designed for receptors. And it also is used to estimate local terrain maximums. Local terrain maximums are a value that Aermap needs in order to calculate something it calls hill heights. So that is a piece of information that's collected by Aermap. Aermap needs both the receptor elevations and terrain maximum heights to run in the default mode. That's our regulatory default. Aermap will generate this data. The basis of the terrain data is a set of digital elevation model, or DEM data. If you've been modeling for a while, you know that this was previously called NED data, National Elevation Data Set. And then before that, there was an older set of DEM data that predated what our current DEM data is. So a little bit confusing there, but currently our elevation files are in the format DEM. If you do decide to run the model that's not in the default mode and you turn on flat terrain, you won't need to run Aermap in advance of any of the flat terrain model runs. Okay, the first thing we need to do in this process for Aermap is to identify the domain. The domain is the area where all of our receptors are located. And then in addition, the Aermap user manual says the DEM array and domain boundary must include all terrain features that exceed a 10% elevation slope from any receptor. That means if I, have a receptor on the ground somewhere in my domain and I draw a line up from that receptor at an angle of 10 degrees, if it hits some terrain feature like a hill or a mountain, that terrain feature is going to be my local terrain max, or could be my local terrain max, and I need to account for that information in my Aermap run. So we may need to cut out a bigger piece of terrain data than just the area that is occupied by the receptors in our file. Now, we have a little utility in BEEST that will help you calculate your domain limits. By the way, during this presentation, I'm going to cut out back and forth between the PowerPoint presentation and an example we'll be doing in BEEST in order to demonstrate some of the things we're talking about here on screen. So again, we're working through the process of figuring out how big your domain should be. What we'll need to do here is from our Show Current Data Graphically screen in BEEST, we're going to select the CalcDom button on the left side of the screen. It's a little red button. And then when we click on that, that pop-up will include its initial guess as to the geographic limits of our domain file. But that just includes the site itself, all of the receptors. It doesn't include the 10% slope area that might be in addition. So what we'll do is we will click Calculate Domain Limits. It's a button on that pop-up screen to have BEEST look at all of the parcels surrounding your current domain and checking to see if there's a terrain feature in any of those parcels that's tall enough that it would exceed that 10% slope criteria. And if it does, BEEST says, okay, well, we're going to need to include that additional parcel in the domain. So after you click Calculate Domain Limits, BEEST will change what it calls the geo limits in this box in order to include both, the place where your receptors are plus the buffer around that includes any 10% slope criteria. Here's a sample BEEST file. This is a small power plant located out in West Texas. We already have sources, we have receptors, everything is pretty much ready to go. We're ready to at least start processing our Aermap data. So again, the first step in the process is to go ahead over here to the left side of the screen to this red box that says CalcDOM and click that button. We should get a pop-up window. This is the list of old DEM quad maps that covers our initial domain that is estimated by BEEST. This is just the area that's covered by your current receptor grid. And then at the bottom, it outlines the edges of that grid with our, latitude, longitude barriers. So what we're going to go ahead and do is click this button on the bottom right that says it says Calculate Domain Limits. That's what we want to do right now. We'll click that button and you'll see on the bottom a little counter. And at the top, it says 9 of 225 analyzed. And it's done. So in this case, nothing changed. It's because this particular site is way out in West Texas. It's extremely flat. There aren't any nearby terrain features that exceed that 10% slope rule. But if we were in a more mountainous area, these numbers would change at the bottom. Okay, now that we have decided on the size of our domain, we're ready to go actually obtain the elevation data. We do this by going to the USGS National Map website, and then we select the box next to Elevation Products, parentheses, 3DEP. Underneath this category, what we're going to go down is select our preferred DEM resolution. Usually we're looking at 1 arcsecond data or possibly a more refined 1/3 arcsecond data. If you're in an area with highly variable terrain or in a valley or something like that, you're going to want to go towards the higher resolution. Otherwise, usually the 1 arcsecond is going to be good enough. Then what you want to do on the USGS side is to select your area of interest. There are a number of different selection tools that are available on the website, but the one that I like the best is the one that says Enter Coordinates or Enter Coords. If you click this button, you'll get a pop-up that asks you to just input the bounding X and Y coordinates of the box. And we've actually already figured out what those are in the CalcDOM function. You just have to take the information from CalcDOM and move it to the USGS. Okay, and the latitude is easy. North latitude is our Y max. South latitude is our Y min. The ones that are a little bit odd are the longitudes. West longitude is our min, and the east longitude is our max. And the thing to remember here is when you put the coordinates in the USGS box, you have to put a negative sign to indicate Western Hemisphere, and in the geo limits, it just says west. So there's no negative indicator there. All right, so you can go to the USGS website directly from the link that I sent you, or from the CalcDOM menu right here, you can click this button that says Download GeoTIFF, and this is going to give you a little pop-up. You want to go ahead and click No to go to the website. and it should take us right here. So this is the website where we just were talking about a minute ago. The first thing we want to do is select the product that we're interested in. So I'm going to scroll down here and look at the products, and we're looking for elevation products, 3DEP. We'll check this little box right there. And then we have 1 arc second data, 1/3 arc second data, a few other ones. I'm going to go ahead and click the 1 arc second, and I'm going to uncheck this. I don't need really refined data for this power plant out in the flat terrain. So I'll go ahead and click that. And then I'll go back up to the top. I want to go ahead and set the area that we're interested in. So I'm going to click on the button that says enter coords. And here's my bounding box. So again, all those coordinates are right here in BEEST. I'm going to go ahead and just copy them in. This is the north latitude. That's Y max. This is the south latitude. That is Y min. The west longitude, that is X min, and there's a negative there. And then the east longitude is this X max, and that is going to be that number. So I'll click add to map, and you'll see this tiny little purple box out here in West Texas. I'm going to go ahead and just zoom in a little bit so we can see it better. This is the size of the domain that I want to cut out of this USGS data. Okay, after we've selected our domain, we're going to go ahead and search products. And then that will take us to a place where we can actually download the links to our TIFF files. And just a quick note actually about the way the TIFF files are named. These are the GeoTIFF files, the DEM data. Each TIFF file is a 1 degree by 1 degree tile, and it has a distinct file name. So this is one of the files that we're going to be downloading here in a minute. It says USGS_1_N something, W something, and then there's a long number after that. This file name actually gives us 3 important pieces of information. The first one is the resolution. In this case, I'm downloading 1 arc second data. So it's just a number 1. The second part is the northwest corner of the tile. In this case, the tile, again, it's a 1 degree by 1 degree tile. So it's that northwest corner is 33 north latitude and 103 west longitude. And then the last bit of information is the publication date. This one, the year is first, so 2021. The month is 11, that's November, and the 24th day, I guess, of November, 2021. So when you go into BEEST, you can tell BEEST to show you your domain. That's from the whatever CalCom has estimated your domain to be. And then the terrain data that we're downloading has to cover that domain. So we're actually going to have to download 2 different terrain files here for this particular project because it spreads into 2 different 1 degree by 1 degree NED tiles. Or sorry, DEM tiles. Excuse me. The northwest corner here again is 33 north latitude and 103 west longitude. You can visualize that in BEEST when you have the grid lines on. Okay, so let's go ahead and download the data for this TIFF file. What we're going to do is click Search Products. And then it's showing me over here that I have 2 different files that I need in order to cover my domain. I'm going to click on them one by one. Down below, there's a link that says download link TIFF. If you click on that, it is going to ask you where you want to put it. Okay, so we've gone ahead and downloaded the data. Unfortunately, the TIFF data that we've downloaded is not in a file that Airmap understands. It's in a compressed GeoTIFF format. So in BEEST, we have a utility called Terrain Files Converter that will take the compressed TIFF data from the USGS website and convert it into an uncompressed format, which is the one that Airmap needs in order to run. Now, one other complication with Terrain Files Converter. Terrain Files Converter needs a reference library called the Geospatial Data Abstraction Library, or GDAL, in order to do this conversion correctly. It doesn't come built into BEEST, so we have to download the GDAL library separately. If you've ever run Airmap before and you've downloaded GDAL, you do not need to do this again. This is a one-time activity, and then once you've done it, BEEST should work, or the Terrain Files Converter utility should work correctly, every time you run Airmap. So before you run Terrain Files Converter for the very first time, you have to download GDAL and link GDAL to Terrain Files Converter. How do we do that? Well, you have to find the latest GDAL data from our website. GDAL updates their files every once in a while, and we're going to have the link in here on our website to whatever version of GDAL works with the current version of BEEST. So you won't need to worry about knowing which one is the latest, greatest version. Once you go to this link, this is on our webpage under the Other Links section. You'll download what's a big zip file for GDAL. We want to download it somewhere on our hard drive and unzip it. I have mine just on the C drive in a folder called GDAL. You can really put it wherever you want, so long as it's a place that doesn't move around. Now, once we've downloaded the GDAL library and unzipped it, we have to actually link Terrain Files Converter to GDAL. So we'll open the Terrain Files Converter utility. We can do that through BEEST. And then we go to the File menu and select Preferences. After we hit Preferences, we'll get the little pop-up that you see over here on the right. And it says, tell me where the GDAL library is. And all we're going to do is paste the path in that spot. So the next time we want to run Terrain Files Converter, it knows where to access the GDAL library. Okay, just to show you how to download GDAL, if you go to our website, providenceforest.com, and go over to the, I think it's resources, other links, other links, and scroll down until we see where is it? Here we go. Under G, Geospatial Data Abstraction Library, or GDAL. If we click on this, we are going to get a big zip file, and I want to put that on my C drive. I've already made a folder called C GDAL. Again, you can put it wherever you like, but go ahead and download that GDAL file. It's downloading. Okay, great. I'm going to go ahead and go to this folder where I've saved my zip file. I'm going to go to the zip file. I'm going to right click, and I am going to unzip, extract here. All right, so I have all my GDAL files in this folder now. I will go, I'm going to minimize this and then go back to BEEST here for a second. Okay, the next thing we have to do is actually link GDAL to Terrain Files Converter. There's two ways to open Terrain Files Converter from BEEST. The first is from our CalcDOM menu. If you still have this up like this, you can go down to this button on the bottom that says Run Terrain Files Converter to do it directly. But if you're not using CalcDOM or whatever, the other way to do it is to go to Run and then go down to where it says Terrain Files Converter. Okay, so this is the Terrain Files Converter. We have to link GDAL, and in order to do that, we'll go over here to the File menu in Terrain Files Converter and scroll to where it says Preferences. in the preferences menu, we have to put the path to wherever we're storing the GDAL file. So I have mine listed as C GDAL. If you don't have yours in there, paste it in and hit OK. And that's it. It's a one-time thing. Now our GDAL, our library has been downloaded and linked, and it's ready to go. Now that GDAL has been downloaded and linked, we're going to use Terrain Files Converter to convert our compressed GeoTIFF file into an uncompressed file that Aermap will understand. So we've already talked about the two different ways to open Terrain Files Converter. We can do that from CalcDOM, or we can do it from the File menu. But once we open Terrain Files Converter, we're going to look on the very first tab, and we're going to browse to wherever we've saved our GeoTIFF file, the one we've downloaded, or however many there are that we've downloaded from USGS. Then we'll create a file name for the output file for the uncompressed GeoTIFF. And what I like to do, just personal preference, is I like to add a prefix at the beginning of the file name, like copy the same file name that the compressed version is, but add something like CONV at the beginning, just so you remember which one has been converted and which one is the original. You definitely don't want to use the same name for the old version of the or the compressed version of the TIFF and the uncompressed version. Okay, after we've selected the files, we are going to go to the Options tab. That's that second tab. It's not showing up here. And click Extract All Terrain Data. And then we'll go on to the last tab in the Terrain Files Converter utility, which is Run tab. And there's literally just one button there that says Run. Click the Run button. It should go through and convert your terrain data and give you a little note that it's been converted. It says wrote the output file, and it'll give you a time and a date stamp. Okay, so I already have Terrain Files Converter open. I want to go ahead and select the GeoTIFF file that I've already downloaded. So it's selected on GeoTIFF. We're going to hit the Browse button and then go to wherever I've saved my terrain files, which is right here. So I have two of them. I'm going to just click on this first one right here, and I am going to copy this Control-C just to keep it in the clipboard so I remember what the file name is, and I'll hit Open. Okay, so that's our input file. Now I need to give the name of an output file. So I'm going to hit Browse again, and I'm going to paste that same name, the same file name in there, but I'm going to write CONV underscore at the beginning, so I know this is the converted file. And I'll hit Save. And now I'll go to the second tab, the Options button. I am not going to, I'm going to go ahead and click Extract All Terrain Data here. And then the last tab, we're just going to hit Run. Oh, okay. On the other window, I had a DOS box pop up for about 2 seconds. And so that looks like that's complete now. I'm going to go ahead and convert that second file as long as I'm here. I'm going to go back to the File menu, and I'm going to browse to, this is the first one, this is the second one. I'm going to copy that file name, hit Open, and then the output file name, this is my new output file name. I'm just going to write CONV next to it. And so that is going to be my converted file. I'll go back to the Options tab, keep that Extract All Terrain Data, go to the Run tab, and hit Run. Okay, yeah, I wasn't fast enough to catch the DOS box this time too. But that is complete. And let me just look in the folder and make sure everything's where it's supposed to be. Not in GDAL. Okay, so this is my terrain files folder. This is, these are the original files that I downloaded, and then these are the converted files. Okay, now that our terrain data has been downloaded and converted into the right format, we are ready to go ahead and run Aermap. So we're going to go to the Aermap menu next. To get to the Aermap menu, we are going to creatively click on the Aermap button at the top of the screen in BEEST, or we can get to it from the Run menu in BEEST, either way. Once we've opened our Aermap utility in BEEST, on the first tab, what we have to do is find our converted GeoTIFF files and click the Add button in order to move them over to the right side of the screen. That will tell BEEST these are the files I want to include in my Aermap run. And then after we select the terrain files in the Aermap menu, we're going to take a look at them in BEEST by going to our Show Current Data Graphically screen and clicking on Show Terrain Limits and Label Terrain Limits. Let me go ahead and do that. Okay, I'm going to go ahead and open Aermap from the AERMAP button right here on the top, Run Aermap. And over on the left side of the screen, we have to navigate to whatever folder is holding our terrain data. I'm pretty lucky it's already in my terrain files folder, so this is where I want to link up my terrain files. Remember, Aermap wants the converted files, the uncompressed files, so I'm going to click on these two and select them, just holding down the Shift button if you want me to select more than one, and then click the Add button over here to move them to the right side of the screen. Okay, so back on our Aermap menu, we're going to click on over to the Aermap Options tab. And in here, you'll see the terrain file type is automatically selected to NED. I know that we're calling this DEM now, but this DEM refers to the old style DEM files. The new style files, which we used to call NED and are now DEM again, that is the format that we want to use, the NED format. The other thing we have to do is add in this anchor location and the zone and the datum. So this project is in UTM zone 13, but I don't have anything in here for the X and the Y. So what I want to do is go to our Show Current Data Graphically button. That's this one at the top that says IN on it. That's going to give us our graphical view of the site. We can click really anywhere in the domain. I like to go ahead and zoom in on the project site, and you want to click somewhere in the white space. Doesn't matter where, but right click, and then there's a button that says Set Anchor Location. So that's it. I've set the anchor location. Now I can go back to my Aermap menu. I'm going to go again, and where's Aermap? Here we go, Run Aermap. First tab, we already have our files selected. Second tab, now this one has our anchor location and user location and UTM location selected here for us. So that is ready to go. Okay, on the last tab in our Aermap menu, we're going to go ahead and run Aermap. At this point, we have to decide whether we want Aermap to calculate both the elevations and the local terrain maximum values needed to generate hill heights, or just the hill height data. Generally, you want to select both. However, if you have better data for actual elevations, maybe that has been surveyed or something, you could input that for your elevations and ignore whatever Aermap produces. And then in addition to the receptors, you can select whichever objects you want Aermap to estimate data for. Aermap was really designed to estimate elevations and hill heights for receptors, but we're also using it to pull out the elevations for our sources, our buildings, that kind of stuff. So elevations are required in Aermod for all types of objects. So usually everything is selected here as well. But the same thing, if you have maybe engineering data that shows what your building and source elevations are, that is probably better than the estimate that is provided in Aermap. So if that's something that you have access to, you may want to substitute that information for the heights of the buildings and the sources, the one that Aermap provides. But either way, select what you want Aermap to do and you hit OK. The OK button on the lower right part of the screen, and then select Run Now from the Diagnostics pop-up menu. Okay, so I'm going to go ahead and go on over to the Run Aermap part of the screen over here. I've gone ahead and selected under Calculation Elevation Options, calculate both elevations and hill heights. I wanted to go ahead and do everything. And then I have selected the sources, the buildings, and the receptors. I don't happen to have any tanks in this BEEST file, but if I had some, I would go ahead and select those as well. Okay, if that is ready to go, we just hit OK. And it's going to take us to a diagnostic screen. If BEEST recognizes any errors, it'll let us know at this point, but my diagnostics are clear, so I'm going to go ahead and hit Run Now. Okay. So I'll get a DOS window that pops up, and the first thing it's going to do is initialize the terrain data. And it says this may take a few minutes. Okay, it really didn't take that long to start processing the terrain. But it went through really quickly and started processing our source elevations, and now it's moved on to the receptors. This is going to take a little bit of time. This particular run isn't too bad, but sometimes these can get pretty lengthy. So you might get to this point and find the Aermap is running really slow. If that happens, that can happen if there are a lot of receptors in your file. It can happen if you have a lot of different elevation files that you're digging through. And it can certainly happen if you have higher resolution elevation data. The one I'm using is just a 1 arc-second resolution data, and I only have 2 files to look through. But if you're looking at 1/3 arc-second data, or you have a lot of receptors, it can run pretty slowly. Now, if this is happening, you do have the option to locally partition your Aermap runs to make them run a little bit faster. If you've run Aermod before or Aermap before, you know that partitioning is a feature that can come in really handy. What BEEST will do on the Aermap side of things is split your receptor grid into pieces. And you can run Aermap basically as many times as the pieces you split it into. But really, the maximum amount of pieces or partitions you want to split your Aermap run into is however many logical processors you have on your computer. My computer, for example, I have 4 logical processors, so that's the maximum I can do on my computer. But you may have one that runs a little bit faster. You could do maybe 8 processors, or maybe you have a supercomputer with more processors available. The only limitation from BEEST is a maximum of 99. So if you are lucky enough to have 99 logical processors on your computer, you can go ahead and set that limit at 99, and it'll run Aermap essentially 99 times faster. And then when all the runs are complete, BEEST will help you merge all the partitions back together So in the end, you have one single set of Airmap input and output files. Just the runtime is going to be shorter. So we're going to show you, for an example here, that if we split our Airmap run into 3 partitions, it's going to run 3 times as fast. Okay, so in order to partition your Airmap runs, you'll need to go to the first tab under the receptor options menu in BEEST, because we're splitting this up by number of receptors in each run. Now, if we go down towards the bottom of that page, there's a selection, or there's a section that says local partition receptors option. There's a way to split the Airmod run, and then there's also a way to split your Airmap run. That's what we're going to do. We're going to select partition receptors next to the Airmap label, and then we're going to select the number of partitions. I'm only going to use 3 because, again, my computer can only handle 4 partitions altogether, but feel free to use up to 99 should you have that many processors available. Okay, after the partitions are designed in the receptor options menu, we're going to go back to our Airmap menu, the same one where we put everything together before. And we're just going to go on to that very last tab that says Run Airmap. There'll be a warning message in there that reminds us that this is going to be a partitioned run, just in case you made that selection and forgot about it. And then you'll go ahead and hit OK and then Run Now to begin. And when you do the partition runs, you'll see several DOS windows pop up that shows you each partition that's all running at the same time. And then once all of the runs have been completed, we're going to go to the results menu in BEEST and select Combine Partitioned Airmod or Airmap runs. We're going to get this window that pops up, and on the upper in the center part of the screen, we have to make sure that we select the map files. That's going to tell this utility that we're merging Airmap files back together, not Airmod files. That's what I have here in yellow. And then in the upper right part of the screen, we need to select whatever partitions that we want to recombine. Once we have our partitions selected, I have those right here, we click the Add button, and it'll add those partitions over here to the bottom left part of the screen. These are the ones that BEEST is going to recombine. Once we're happy with that, we go to the bottom right and click Combine. And that's it. I will show you in the sample file here what that looks like, but then we'll be able to visualize our Airmap outputs. All right, so let me go back here. I know I want to run Airmap, and I want to run it faster, so I'm going to go to the receptors menu up here at the top. It looks like 4 little dots. And then I'm going to look down here to where it says Local Partition Receptors option. Right now under Airmap, it says Do Not Partition. I'm going to change this to Partition Receptors, and I'm going to change the number of partitions to 3 because that's probably all I can get on my computer. And then I will go back to our Airmap menu. Just did that here from AERMAP. And I'm not making any changes to this or this. I'm going to go all the way to the last page here where I can run Airmap. And it's giving me an error because it looks like I tried to run this already, and it's telling me it'll be overwritten. That's totally fine. And then I have my little warning at the bottom left that says the Airmap partitions are set to 3. Just don't forget you're doing a partitioned run. So I'm going to go ahead and hit OK. And I get a diagnostic screen. Everything looks fine. So I'm going to click Run Now. And then I am going to get these opened in another window, but I'm going to get 3 different windows that pop up here for my different partitions. They're all going to have to do the initializing. I think that is going to be pretty much the same time frame anyway on all 3 partitions. But once the initializing is finished, these should run quite a bit faster. All right. Okay, so here are all the runs. This one has 553 receptors, 553, 553. If I come back here, I can see that my total receptor grid is 1659. So it just divided up all of those receptors into different pieces. I'll come back here in a minute as soon as the runs have completed. All right, it looks like we're nearing the end here. Okay, 2 of the partitions have completed. This last one is hanging on. Okay, so all of our partitions are done. If we look at our file where we're storing everything, we'll see all of these partitions, the O1, the O2, the O3. Now we need to merge everything back together because the partitions aren't really going to do us any good in the long run. So to do that, we're going to go to the results menu, sorry, and then go down to where it says combine partitioned Aermod or Aermap results. And then we'll get a pop-up that looks kind of like this. Now it should go to whatever folder your BEEST file is in, but the default for this utility is to think you're recombining Aermod files rather than Aermap files. So you have to click on this little button here on the side and go down to say the map menu, because we're looking for the map files, not the mod files. Okay, once that's selected on the left, on the right, we're going to go ahead and highlight all of the partitions. In this case, I only have 3 partitions. I'm going to highlight all of them. And then I'm going to go ahead and click the Add button. And that will add my partition to the bottom right of the screen. You do have the option here to check this box to delete the individual partitions after they get combined together. I like to do this because the partitions aren't helpful really to me later. But if you wanted to keep the partitions around, don't check that box. And then I'm going to go ahead and hit combine. And it just takes a second. It says files combined successfully. And because I click that box, it asks me, you sure you want to delete the partition files? And I'm going to say yes. Okay, so everything has been recombined. Okay, we're going to take a look at the results from our Aermap run. I'm going to hit close here on our combining window, and then we'll look at our show current data graphically window. That's the one at the top that says in on it. It looks like I've zoomed in on my plant a little bit. I'm going to zoom out just a little bit because I want to focus on the receptors. Let's look at these over here. And in order to visualize the elevations and the terrain maxima information, we have to turn on this receptor elevation button here on the left. There's a button that says BEEST is showing us the receptors, but it's not showing us the elevations. So if I click this, it shows us both the elevations, those are in green on the bottom, and the terrain maximum information, which is where it looks for anything within a 10-degree slope. And if there's something higher, it'll put that terrain max in there. That's what's in black at the top, the terrain maximum. You might notice on this screen, all of these numbers are the same. The terrain max and the elevation is the same. And it's just because this area is pretty flat. So there's no difference between the elevation and the terrain max. Okay, so we've taken a look at the results from Aermap. The bottom number again is the elevation. The top number is the terrain max. We can also see the elevations and the terrain max information in our receptors menu, and then the resulting elevations for sources and for buildings in our sources menu and in our buildings menu. Okay, just to verify, I'm going to go ahead and click on the receptors menu over here, the top white one with the 4 dots on it. I'm going to click on that and then go over to where it says discrete Cartesian. And you'll see the original coordinate, the elevation, and the terrain max, and that will be in there for all of our receptors. If you want to see the elevation of the sources, click over here on the source options menu. You can click on each source individually and it'll tell you what the base elevation is here. It's 944 meters, or the grid view. That information is in here as well. Similarly, it should be linked with all of our buildings and tanks. That's in this yellow menu up at the top. It says fence lines, buildings, and tanks. We'll go over to the buildings. I don't have any tanks in this particular run. And I'm going to click grid view. And this is a list of all of our buildings. And now our base elevation column is filled out by Aermap. And so that is how you can run Aermap from BEEST and view the results. My name is Leslie Fafita. I work for Providence. Please feel free to send me an email or give me a call if you have any questions. Thank you very much.